Okay, so in this session, we will be continuing with the topics that we have discussed in the last class. The topic was ROS Nodelets, and we have mentioned that the ROS Nodelets is actually like nodes, but the underlying technique that is used in Nodelets is different. So instead of communicating from different process in ROS Nodelets, there is only one process, but the modules or the plugins are running as separate threads, and each module is doing some computation. So the Nodelets are very useful in image processing and point cloud processing. So today we will be seeing some demos of OpenCV and mainly OpenCV applications using Nodelets. So which is already available in ROS repository. So we will be like seeing that, and then after the demos we will be like going to the next topic, which is ROS Gazebo plugins. So we will be seeing some part of the plugins in Gazebo, and we will first see how to write a Gazebo plugin, and then we will see how to write a ROS Gazebo plugin. Okay, so that is a plan for today's session. So let's start. So I have mentioned a package yesterday, which is OpenCV application. So this was the package that I have mentioned, and I already mentioned that like this package is actually the implementation of OpenCV APIs in the form of Nodelets. For example, if you want to do an edge detection application, then this application is having the Nodelet implementation, and you can simply pass your image into this Nodelet, and the Nodelet will do the job, and it will be publishing the edge detected image. Okay, so I'm just sharing this link again. So if you just scroll down, you can able to see a set of examples, like starting from edge detection, then we can see the output, then half lines, then half circle, then fine contours, convex hull. So these all are some general examples of OpenCV. If you just go through the OpenCV repository, you can able to see this. So in this OpenCV apps, they actually implemented ROS Nodelets version of it. Okay, so you can see, almost all the examples of OpenCV are converted into Nodelets. Okay, so there is even face detection, then face recognition. It's not based on the deep learning or something. It's based on classical image processing techniques. People detect is their motion analysis and camshaft. It's all based on OpenCV examples. Then optical flow, like for motion detection, we have a algorithm called Fernbach and Lucas Canaday. So these are two classical image processing algorithms available. So we can see the application. So the limit, the number of applications are like, there are a lot of things. So even there is a object segmentation, watershed segmentation. Okay, so you can see the number of applications that they created based on Nodelets. Okay, so you can take any one of these examples as an example for your node. Okay, and anyway, like first start with the demo, and then we can go through some code as well. Okay, so yesterday we have seen a very basic Nodelets, which is like hello world. So what we have done was we have created a Nodelet code which is simply subscribing to one topic and publishing that topic. So, and we have created two instances of that Nodelet, and then we have published a string topic into it, and we got the output. Okay, so similarly I'm planning to try with these examples. So I'm working from VMware. So first what I have to do is I have to add my webcam. Okay, so if you are working with the real Linux PC, then you don't need to add, you just need to connect the webcam and make sure you are compatible. I mean the webcam is compatible with the with Linux. Okay, so if you check the cheese application, before checking the cheese, if you are working with the VMware, you have to add this camera, connect the camera to the VMware. If you are working with the real PC, you can simply open the cheese. Okay, so what I'm doing is I'm planning to connect the camera to Linux. Okay, so after connecting, maybe in order to make sure everything is working, after connecting the camera, just do dmessage. Okay, dmessage. So this will be like giving the kernel messages, and you can find like it's actually registered. It found the UVC device USB camera, and there are some errors as well, but let's see whether it's work using cheese first. Okay, so cheese maybe by default may be available, so taking cheese, and then you can see me. Yeah, here is my view. Okay, and I'm just closing it. So I just made sure that the camera is working. Okay, now it's a time for just launching the launch file that is created. Okay, so I'm just taking the OpenCV apps repository in Git. Okay, so this was the repository I think I have shared yesterday as well. So this is the OpenCV apps repository, which is having tons of examples. So you can simply see there's a launch folder. Okay, so all these launch files are for starting some applications. So maybe we can start with the edge detection. So if you just go to the edge detection, just a second. Yeah, edge detection.launch. If you click it, you can able to find like it is loading the Nodelet. So here there are some parameters, and then it is starting some nodelets. Actually, you can see here it is starting a node, and the node actually is loading the nodelets. Okay, so I think I can just show you that. Just a second. Okay, so for the nodelet, you can see here for the edge detection. So there is an edge detection nodelet. So like for creating any like any OpenCV based nodelet, I will suggest you to take this class OpenCV apps nodelet, and it will be easy if you can create application inside this package itself. Otherwise, it will take some time to extract this nodelet base class from this package and put it in another package and set up. Okay, so in every OpenCV ROS application using nodelets, what is happening is that it is inheriting from a nodelet base class. Okay, which is having some definition. Okay, OpenCV related things, and then after that they are like mentioning the parameters required for the edge detection. You can find, and then there are different. We are actually seeing some extreme example. Like first we have seen the basic example with the hello world. Now we are seeing like the OpenCV examples. So you can see some difference for sure, because these functions are like defined in the base class, and we are actually like overriding it. So some functions, okay, and the do work function is doing the edge detection and everything. Okay, so whatever the process is, it's simply a nodlet. Okay, it's simply a nodlet which is having the same structure of the basic nodlet, but the see if you learn any technology or any techniques, the things that we can do using that technology is infinite. I mean, the scope, like that, using nodlets we can do like image processing, point cloud, and many more. So this is the nodlet thing. And actually what they did was they actually created, I think, a node which is actually loading these nodlet. So let me check that actually. So if you just go to the CMake list, you will get how these things are compiling. But again, it will be slightly complicated because it's a big package. Include OpenCV. Yeah, so here is adding the nodlets. Okay. Yeah, so each yeah, so you can see here, edge detection, no, edge detection is actually compiling the edge detection nodlet. Hufflines is compiling the Huffline nodlets. Okay, so you don't need to worry about this macro and all. Just understand that like they are compiling these nodlet, and I think that nodlet itself having the loader. Let me just check. If you just go to, let me check if there is any main function. No. Okay. Yeah, I think it's a pure nodlet. Just a second. There is a query. Is it possible to visualize RQT of nodlet? Yeah, I think yesterday I have shown that like it will work like the nodes. Okay, so we can visualize in RQT. So I will show you that. Okay, yesterday I have actually shown that. Okay, so maybe first we can start with the demo, so you will get an idea, and then we can see each applications. Just a second. Okay, right. Yes, so let me start with the first application, which is edge detection. So in order to start this application, what you have to do is simply launch the launch file. So maybe I can start one by one. Okay, so I'm just starting the edge detection. Okay, so this is the edge detection launch file. Okay, so if you just start, you can able to find it is not doing anything. Okay, it's not doing anything. So what is happening, like when you start the edge detection, it's actually started the edge detection, but we didn't provided any input to the edge detection algorithm. I mentioned that nodlet will be, I mean, nodlet and even nodes will have some topics for publishing, some topics for subscribing. So I am just saying the subscribing topics is like inputs and the publishing topic is like output. Okay, so here also, like if you check in RQT, maybe you can see that that node. Let me see. So this is the node that is available. Okay, edge detection. Okay, node is available, and then what you can do is you can simply check the topics. Okay, ROS topic list. So then you can able to see some topics, and yeah, some topics here. There is a topic called image. Okay, so we can check ROS topic info image. Okay, so now you can find this image. No, this topic is actually subscribing by the edge detection. Okay, so from the topic itself you can just guess which will be the input and which will be the output, because if you see the namespace like this, then you can find this will be the published image, meaning output, like the edge detected output. Okay, and the image is actually the input. Okay, so in order to make this edge detection working, what you have to do is we have to provide the image. Okay, so where is the image source? The image source is actually, like, we are taking the camera as the image source, right? So what I'm doing is, I think I have shown you this before, I'm starting the ROS driver for the camera. Okay, so what the ROS driver does is that it's actually reading from the camera and publish a topic. Okay, that topic will have the images from the camera. Okay, so the USB cam package is a famous package available in Synaptic. Not Synaptic, in apt-get you can simply install the USB cam package simply by using the command like ROS Noetic USB-cam. Okay, so this driver will be installed, and then if you launch it, what you will get is, you will get the driver ready, and then this window, this window is actually RQT image view. Okay, so you can visualize the image. Okay, so now after running the driver, what you can do is, you can again simply check the topic, ROS topic list. So now we got lot of topics, like these much of topics was from the edge detection, and this was the input or subscribing image, and these are the topics from the camera driver. Okay, so there is USB cam image row, which is actually the published topic from the driver. Okay, and also there is a compressed version, but we need to provide the raw image to the edge detection. Okay, so you can see here, this is the published topic and this is the subscribed topic. Okay, so in order to give this image topic to this, I mean, we have to match the input and output, right? Either image topic should be matching with the USB cam image row. Like if the driver is publishing the image as a topical image, then it can subscribe, but there is a mismatch in the naming, right? Because input and output is not matching. So what you can do is, this is actually a quick fix for that. There is a node called relay. Maybe I can show you that. There is a package called topic tools. Okay, so this is an important tip, I think. If you just search for topic tools ROS. Okay, this package. Maybe I can put it in the discussion channel. Okay, so this package can use for like republish a data, but it's not very efficient, but I'm just showing for the demo. Like we can do a remapping or relay. Okay, there are many methods. We can change the topic name in launch file, or we can do, but for a quick fix, what I'm doing is I'm using this package and I'm using relay node in order to remap or republish the data. It's not efficient actually, but this way you can able to republish this data. So what I'm doing is I am running topic tools relay. Okay, relay. Then I am putting the input topic, which is the USB cam image row, and the output topic, because that is the topic that we need to you can say like this, like this is the topic that is publishing by the driver. Okay, but this is the topic that is subscribing by the edge detection. So you can simply run the relay. Then what happening is that the input and output is matching, like the driver image data is going to the Nodelet, and we are getting the edge detection output like this. Okay, and there is a thing called RQT dynamic reconfigure. Let me show you that. So currently it is working, and I can show you the nodes. So you can see here the USB cam is publishing the topic called image row, which is getting relayed, and it's going to the edge detection. Okay, and there is a visualization of the image as well. Okay, and there is another thing called dynamic reconfigure. Let me check that is working or not. Back. Yeah, dynamic reconfigure. Let me see. Okay. So I'm not sure you heard about the dynamic reconfigure. The dynamic reconfigure is that you may heard about the ROS parameters, right? So ROS parameters are like static variables. Like you can put the ROS parameter inside the launch file or in a YAML file, and once it is set, you have to like reinitiate or set it again. Okay, set it again for changing the value. We can change it, but there are some problem with that, because if you want to see the change of some process after changing the parameter value, for example, I have a color detection program. Okay, color detection program. So if I want to change the threshold as a ROS parameter, then whenever I change the threshold, the detection has to change. Okay, so normal ROS parameter will not do the job. Okay, so for that, ROS 1 is having dynamic reconfigure. It's like the ROS parameter. It's a modified form of ROS parameter, and using this, if you use the dynamic reconfigure APIs in your node, then you can able to change the parameters using this dynamic reconfigure plugin. So if I am changing the threshold and all, it actually like having some variation. Let me check. So using these thing, you can simply switch the edge detection algorithm, and yeah, so even you can change the threshold. Yeah, so there are a lot of methods that you can do to fine-tune this detection. Okay, so these dynamic parameters are like, whenever you change the value, it will be getting reflected on the image, which is actually good, right? Because rather than setting the parameter and then starting it again, we can use this dynamic reconfigure thing. Okay, so yeah, so this is the way we can do the fine tuning of the algorithm. Okay, in the Nodelet. Okay, and also yes, so this is a way I can change the parameters here. Yeah, okay, so this is how we can able to run it. Okay, first you can start the edge detection or any launch file. Then you can map the topic from the driver. Okay, and then you will get to see the output, and you can change the parameters using dynamic reconfigure. Okay, so that is for the edge detection, and we have many more demos. Like maybe I can do once more, and you can also try from your side. This is a very interesting package. By the way, I forgot to say how to install this package. It's very simple. So just go to Synaptic. So I hope you have all installed apt-get Synaptic package manager, which is a GUI tool for apt package manager. So just search for OpenCV apps. Okay, OpenCV-apps. So you will get two packages. One is ROS Noetic OpenCV apps, and one is ROS OpenCV apps. Okay, so you can install any of this package, but I think you have to install both of this package. Then it will be installed on your PC, and you can simply start this application. Okay, and you can also build this repository if you want to create new OpenCV application. The easiest way is like just clone this repository, then create your program on this folder. Okay, in the Nodelet folder, and then you can add it on the CMake list and build. Okay, so there are many examples available. Using this example, I think you can make it work. Okay, so yeah, so maybe I can start one more. Let me check. Face detection, maybe let me try face detection. I don't know like it will work or not, but let me try. OpenCV apps, face detection. Yeah, it's actually require the detection file. Let me see I can install it using Synaptic, because basically the face detection using the classical image processing techniques. So we have to install the face detection training file. So let me see if that is available. OpenCV data, I think it's there. Python OpenCV application. OpenCV seems like, or we have to provide that in the launch file or something. So if you take the face detection launch file, you can able to see a path to find the trained file. So you have to change this file. Okay, you have to change this file, otherwise it will not work. Okay, so it seems like it's an argument, and this actually have to pass to the face detection Nodelet. So I don't have this file now. I can download it maybe. So you can use this application for detecting face, eyes. I mean, if you change the XML file, you can change the detection, something like that. Okay. Yes, so maybe we can just post that face detection because we need that file. Maybe we can do some motion detection. Just try the FB backflow. So FB backflow. Okay. Seems like it is starting, and now we can check the ROS topic list, and then you can see the input topic, which is subscribing by the Nodelet. FB backflow Nodelet is image, and the output will be backflow image. So I mean, from this list itself you can just guess. Okay, so now you have to provide the image. Just start the driver, and then you can load it or relay it. Now you can see what is happening. Okay, so here you can see whenever I move, you can see a vector or some direction, right? Okay, so this this algorithm called Fernback is actually for detecting the motion. It's not only for just for detecting the motion, but it can also find the direction. So for example, if I am moving the hand in this direction, the arrows actually pointing on that direction, right? So from this we will get an estimate, like but if it is a very fast movement, yes, it can detect, but if it is in a controlled environment, I think it will work perfectly. And if the motion is very slow, we can able to like track it very very accurately. Okay, and also you can like fine-tune the motion detection using RQT dynamic reconfigure. You can see here, but I think there is only very less parameters for this. Yeah, for this it's almost like fixed parameters they are using, so there is not much I mean parameters for fine-tuning. But you can able to see, right, it's perfectly detecting the motion and its direction. Okay, so I think we can just stop this thing. Like I hope you got an idea about like the application of Nodelet in OpenCV. And regarding the PCL Nodelet, so if you let me see if there is an example there is a good example that we can get using the voxel grid, which was one example that I was looking for. Just a second. Let me see. Yeah, let me check if there is any example launch file we can get without writing voxel grid ROS Nodelet launch file, so that we can immediately take it and we can test it. Okay, yeah, I think we have in the tutorial itself they have provided the launch file for loading the Nodelet. Okay, so I think we can test this. Okay, and after that I will explain. So yes, so what we will do is we can simply copy this launch file. I mentioned that like the Nodelets can simply start from the launch file. We don't need to write anything. Only thing is that we have to like remap the input, and then you can give the name of the output and also some parameters. Okay, so just copy this launch file, and they already mentioned the instruction as well, how to run this. Maybe we can have a try. Maybe I'm just putting this launch file in some workspace, I mean some packages, maybe hello world. Okay, I'm just putting this in a new file, voxel test dot launch, and then I'm just copying the launch file thing into this launch file. So I will explain it. Okay, after showing the demo I will explain it. and I'm also just changing the permission to executable. That is not very required, okay, but it's fine. So we have the launch file here, and just a second, and we need to like give the input, the point cloud source. Okay, we can use the point cloud source as depth camera, or you can use a file, point cloud file, or any point cloud source you can, or lidar or anything. Okay, so for me, what I am planning is I have some PCL nodes which is publishing the point cloud data from a file. Okay, so let me just check that. PCL test, it's not PCL test. Let me check. I think we already tried that. Maybe it may be in the Catkin workspace. PCL ROS tutorial, right? Yes. Okay, so let me try this. So the objective is that publish the point cloud, okay, from some sources. So ROS run, then PCL ROS tutorial, then PCL publisher. Okay, so this PCL publisher node, okay, I think this node will be also fine. It will be publishing a random point cloud, that is also fine. Okay, so you can set the sources, maybe this node. I think I put this node in our repository. Okay, so what this node does is that it will be like simply publishing a point cloud. The shape is like a cube, and I think you have seen that before, and the frame ID is point cloud. Okay, so when you run this node, where is that? Okay, it will be running, start publishing the point cloud. Okay, so we got the input topic. Yes, so this is the topic that is publishing. I mean, it is having the point cloud data. Okay, so what we have to do is we have to just copy this topic to the launch file, and we have to give here, because that is going to be the input to the voxel grid. Okay, I will explain what is voxel grid is, but just want to I mean, do the demo first, and after that, so we got the input. Let me close it. Okay, and then we can start the launch file. Okay, let me see, where is the launch file? Hello world. Okay, it's in the hello world. Okay, so using ROS CD, we can exactly find out this package, hello world. Okay, so now the package, actually, I mean, there are two packages in different workspaces. So there is a workspace called learn ROS workspace. So the hello world is detecting from this workspace. So anyway, like, it may not be properly sourced. What I'm doing is I'm just copying this launch file to learn, where is that? Okay, learn ROS workspace, then hello world, launch file, launch folder, and then I'm just copying it. Okay, and now what I'm doing is I'm just executing the same command, which is ROS launch OpenCV apps, then not OpenCV app, sorry, hello world, and then the voxel test. Okay, so just want to run this launch file. Yes, it is executing. Okay, it is actually getting okay, the node subscribes a topic only when okay, got it. So let me check. Anyway, this is actually publishing the topic, and let me just take RVs just for seeing the output. Point cloud is the frame name, we have to give that, and then we can check the PCL output. So this was the input PCL. Okay, this was input, and if you just check the voxel output, you can see I mean, it's actually different, right? This is the input and this is the output. Okay, so we didn't do any programming or anything. Okay, the voxel grid filter in ROS, I mean in PCL basically, it's actually for downsampling the data. So if you have a chunk of point cloud with you, then you can downsample the point cloud using the voxel grid filter. Okay, so in order to load the voxel grid filter, you can simply load it using the Nodelet, and then just provide the topics, and then it will do the processing. Okay, so that is what we are getting here. Okay, so this is a processed point cloud, and this is the input point cloud. Okay, so I mean, some portion of the point cloud is cut off, right? That is actually here. Okay, so that is one manipulation that we have done for the input point cloud, that is actually publishing from this node. Okay, so this node is basically publishing a PCL data, and you can visualize that. And then what we have done is just create this launch file. Okay, you can put it in a new package or any package that you want, and then just map that input, remap the input, and then it's done. Okay, so similar to that, you can check any filter tutorial. So if you check the pass through, just copy this launch file again to the existing one, and then change the topic PCL output, and then do the same. Okay, do the same, and it is working. And now we can check the output in RVs. Okay, point cloud, now we have the input here. Okay, and we can simply change the topic to voxel grid output. Oh, okay, sorry, I think voxel grid, I think it's running on the same but it's actually different. Let me check. We actually changed the launch file, but let me check where it is changed. Oh, okay, got it. It's actually the old workspace. We have to change here, right? Okay. Yes, now it will work. Voxel test, right? Okay, So this is the output and this is the input. I mean, the filter is doing something that we need to like look onto the filter configuration, but there are some kind of manipulation is doing by this filter. Okay, so all these instructions are available in the tutorial, but this is actually for doing some manipulation for PCL. Okay, so we have seen how to do how to work with the Nodelets in OpenCV, and in PCL there are some existing Nodelets like this. You can simply use this, and then you can fine tune these Nodelets using dynamic reconfigure. Okay, so this is an abstract thing, so you can simply learn more from these tutorial. I think I already sent the tutorial link. Okay, so this is how we can able to work with the Nodelet. You don't need to write any code, just try to find any Nodelets is available, just run that Nodelets in the launch file and then map the input and output, and then you are done. Okay, something like that. Okay, so I think we can just conclude this Nodelet stuff. We have seen most of the stuff like tutorials, then the basic programming, all this stuff, and now I just need to switch to a new topic. I think we can't able to finish it anyway, but I can start with the basics. Okay, and then I think we can continue with the next week. Next week maybe I can finish with this and then start discussing maybe these two topics. Okay, these two topics again. These two topics are like an advanced concept, but again there is not much into to discuss. I mean, it's very specific actually. Okay, so it is not broad actually, it's a narrow topic. Okay, so yeah, so this is all with the Nodelets, and now we can switch to another topic called Gazebo plugins. I'm not talking much about it now, giving a basic idea. Okay, now we can discuss it later. So I'm not sure you have heard about the Gazebo simulator that is coming along with ROS, which is actually like an open source simulator. I'm not very impressed with the simulator, but it is tightly integrated with ROS. That is actually the advantage. But if you compare with the other existing simulator like WebBoards or like VRAP or Copilot Robotics Sim, the Gazebo doesn't have much appeal. I will say it's not very appealing, but it will do the job. Okay, the job is robot simulation, and the highlights are like it can simulate various scenarios, but regarding the graphics wise it's not appealing. Okay, but we can do a lot of things using it. And when you see the simulator, you will be thinking like how to work with simulation, because it's not very easy to start working with Gazebo. It is mainly having the 3D viewport with a very limited menu, but everything is doing in the programming side. Like you can create plugins. You can extend the capabilities of Gazebo by writing plugins and all. Okay, so maybe we can simply see the Gazebo first, and then we can discuss about the plugins and all. Gazebo, ROS, empty world, or yeah, empty world will be fine. Okay. Yes. Okay. So you can see here, this is Gazebo. Okay, and the Gazebo, when you install ROS Noetic desktop full, you will get the Gazebo along with it. Okay, it's actually bundled. The ROS noetic packages are bundled with Gazebo. And if you see the options, there are some menus and all, but these menus are very basics. Okay, we can't do any simulation using this menu. uh, Very basic kind of things like some meshes, some primitive shapes, and you can do some manipulation of these shapes. And it's actually having some physics engines, and you can find um, these kind of simulations. The real world it will work like the real world, almost work like the real world, yeah. So you can simulate robots, and also like these kind of rigid body. And yeah, but you can see it's not very appealing. The graphics is also not very good. But maybe we can first see some of the features of this Gazebo. Okay, so the question is, why should we learn Gazebo? That's a question, right? Because I already mentioned it's not very appealing. And so there are some advantages as well. Okay, the first advantage I will say, the community. Okay, the community, because when you start with something, no, you should need some support from the community. Okay, sometime you will be enrolling for a course for understanding about that framework, like this course. But the thing is that if there is no community, there will not be much courses related to that topic. And so the community is very, very important. So Gazebo is having a very good community around it. So that's actually a positive thing. And the Gazebo can be extended by writing plugins. Okay, that's a next positive thing. So if you want to simulate a specific sensor, a new sensor maybe, you can write a plugin for that, and you can simulate the plugin, new sensor plugin in Gazebo. Okay, and the next positive is that it is having the physics engine, and you can create realistic simulation. But the graphics part is not that appealing, but it will be a realistic kind of simulation we can simulate. And then the next is ROS support. So the Gazebo is actually an independent simulator, but it can be extended. It can be connected to any frameworks such as ROS. So basically, we can extend the capabilities of Gazebo by writing plugins, right? So similarly, there is a strong or very stable ROS Gazebo plugin, Gazebo ROS plugin. That is the name of the plugin. So what we can do is we can just communicate to Gazebo using topics and surveys. For example, if you want to simulate a lidar sensor in Gazebo, you can use a ROS lidar plugin. Okay, and you can load it into the Gazebo. And what happen is that the lidar will be simulating, and then the simulated lidar will be publishing as a ROS topic, which is actually the best part of it, because you can simulate sensor, actuators, or any controllers in Gazebo, and you will get the topics, service, action, communication from ROS side. Okay, so like that, there are many advantages, and that's why we are using Gazebo. And also there are some other simulators like Isaac Sim from NVIDIA. So but there are a lot of limitation in it. Main limitation is in the hardware. So they are actually doing it for the NVIDIA boards, and we may need some NVIDIA graphics card or some Jetson board to work with it. And the one of the negative is the community. Okay, so if there is not much community around simulation, the people will not adapt to it, but it is giving good visualization and very realistic environment. You can see here, okay, because using the rendering NVIDIA, with the help of NVIDIA graphics card and all, it can create a very close simulation environment to the reality, I will say. Like, yeah, but and also it is having ROS 2 ROS 1 interface, but in order to set it up, it will take some time, and it's not very user friendly as of now. But I think in future you can create like very good simulation using this kind of simulators. Okay, and you can use it for a product demo as well, product video. So this is actually from the simulator. Just see how good it is, like when you compare with the hardware and the simulation. It's more, I mean, the simulation is very good, right? I think it's a replication of the actions performing in the simulation in the hardware. So like it's very smooth and very appealing, right? So this kind of simulation environment, NVIDIA is actually pushing it, because the main objective of NVIDIA is to like sell their hardware. So around this hardware, they have to create a community, especially like a software based community. Then only people will use their hardware. So there is nothing wrong with it, but one problem is the dependency. So if you don't have any NVIDIA machine with you, then you may can't able to work with this kind of simulator. Okay, so that is one dependency. But if you have an AMD or like what was the name, Radeon, yeah, Radeon graphics or something, you can't able to work with this. So that is actually a problem, but they are working very hard to integrate ROS and integrate deep learning and all this stuff. So you can see here, this is a software stack of Isaac. So here we need RTX, then SAS. I mean, this is the hardware platform they are suggesting, and on the top there is I mean, variety of library from NVIDIA. So very hardware specific, and also they are NVIDIA is pushing with their software as well. Okay, so if you want to do a simple simulation, I don't think I mean the Isaac will work. It will not be much faster, but if you want to do it for a product, I think I will suggest Isaac, because it is having that kind of visualization and all. Okay, so this is one simulator that is actually a competitor for Gazebo, and the simulator that I like is WebBoards, which was actually a proprietary software, and it is compatible with all the operating system, which is having good graphics, but not that better compared to Isaac Sim. But I think at least better than Gazebo. Okay, and the advantages are like there is a good programming environment or good programming interface for WebBoards, and so you don't need to like go to terminal and need to program. It's all available in the GUI itself. Okay, you can program using the C++. Yeah, Tejas is having a question. Yeah, what about AirSim? Yeah, so I actually worked with AirSim when they started the project, mainly in drones. When I was working with the CMU, they actually did some work in AirSim. So AirSim is from Microsoft. So they have the capability of Microsoft is the DirectX. Okay, I think you heard about the DirectX, which is using for games. Okay, so AirSim is actually I think uh, Unity or Unreal Engine based. I think it's Unity. They changed to Unity. Yeah, it's Unreal. Okay, they are also working with the Unity engine. So these engines are mainly using for games. So if you see the AirSim, it will be like looking like a game. Okay, so they started working for the first. I think they started with self-driving car simulation. Then they started the drones by default, but you can simulate any kind of environment. But again, now I don't know like regarding the community, but at that time it was not very good, but we can able to like create this kind of simulation using Unreal Engine. Okay, but if you just compare this with Nvidia, I will prefer Isaac Sim for the better quality graphics. But this is also okay because for the drones now, drones need a very big environment. Okay, so and also AirSim is not only providing the simulation, they are also providing some synthetic data. Like when the drone move, it is actually getting up, I mean, coming with some like some depth image and also some other things. So yeah, Tejas is having question. Even Isaac Sim front end is Unity, right? Yes, but this is Unreal. ASM is actually based on Unreal, but they are working on Unity. So you can see here, ASM is a simulator for drones, cars, and more, built on Unreal. Okay, we now also have an experimental Unity release. So the Unity may be much better, and the advantage that Isaac Sim get is that they have the rendering capability, right? The Nvidia is having. So but the Microsoft is mainly focusing on the DirectX. Okay, so I think Nvidia is having some edge over Microsoft regarding the visual aesthetics. Okay, so that is what I'm thinking because they have yeah. So I don't know like when AirSim completely release the Unity version, it maybe us better than Isaac Sim. But now I think it is like Isaac Sim is much appealing for me actually at least. And there are many other simulators available. Another is Copilia Sim. This is another robotic simulator, but it's not very appealing, but you can do a lot of things very easily. Okay, and it is having I mean a lot of features like ROS integration, MATLAB, lot of integration, but the graphics will be like it's not like uh, a real I mean you can watch it like it's not looks like real, but it's not very bad as well. Okay, uh, yeah, you can see the simulation. It's very user friendly. You can create a simulation very quickly from the CAD model, and you can control the robots using Python API, C++, and ROS APIs. Okay. Yes. Yeah. So Tejas is having a question. Nvidia has an edge, but you rightly pointed out that they are doing it to promote the hardware. We are exploring. Yes, yes. So, yeah, so that's the thing. Like for every business, I mean, they're actually exploring the possibility how to sell the hardware. Uh, I mean, in a big scale, right? So, uh, they are creating a community actually. Like they have seen an opportunity with ROS and its community, so they are working hard with ROS team to work with to integrate ROS to Isaac, and also they are also working with navigation stack, I think, ROS 2 navigation stack. So then only like they have an edge over other vendors, and mostly like these hardware companies are competing for getting this market, because there is a thing called first time advantage. First, I mean, whoever starting first, they have some advantage. Like when another player come into the same market segment, then they have to beat or they have to excel the existing competitor. So that will take some time. So I think that's what I felt. And also there is a very good research team behind Nvidia. I know personal, I mean, in my connection as well, a lot of people are there. And also Nvidia is actually a kind of sponsor. If you check our page, I actually talked with Nvidia in US, and they are actually helping us with their topics. But I mentioned that I'm not promoting Nvidia things for the business. It's just for the knowledge, because yeah, so Nvidia is actually Nvidia and Nvidia embed. I have some friends in Nvidia in US, so they actually having I mean, they already have a lot of stuff in ROS 2. So if you just check ROS 2 NVIDIA, you will get a ton of projects, mainly using deep learning and all. So uh, I was just thinking like introducing these things in some way, maybe helpful. Okay, but it's not like saying like you have to use NVIDIA for this, but that is actually not good. What I am preferring is that just give an idea about the list of things that is available. Okay, even I am partnering with Nvidia for the education, I'm not saying Nvidia is the best. I'm seeing a lot of difficulty. Even I have faced difficulty in setting up Isaac sim in my computer. So yeah, but it will be good for like a product video or something. Yeah, so that's what. So I hope you got an idea about like the simulations available and the situations of gazebo, and what are the things that we can do with it. Okay, and by the way, like in competitions now, like there is a competition called the DARPA challenge. I'm not sure you have heard about the DARPA challenge. It's a very famous competition, and like the self-driving cars like evolved from the DARPA challenge. The pioneers who worked with the DARPA challenge in 2007, their team actually acquired by Google. Then Google started working on like the commercial version of DARPA challenge. And these DARPA challenge, actually in the last DARPA challenge, it was about exploring robots in like caves, very tough environment. Okay, so actually for the simulation they have used gazebo. It's a sub-T challenge. Okay, I was involved in sub-T challenge the initial phase, but then I actually dropped. Sub-T is mainly for working with very difficult environment. uh, yeah, so this was, I think, for the first challenge or something, CME was the winner. But then I think I forgot, some university from Europe, I guess. Okay, so you can see here tunnels. Okay, urban underground cave networks. So these environment, no, these are very difficult to explore. So the objective is like go through this environment, map it, and come back, something like that. So you can use a combination of robots, like you can use legged robots like Spot Mini or Spot, and then you can use drones, you can use wheeled robots. Okay, you can use any combination. But working on these caves and tunnels now, you can think about the Wi-Fi. The network will be limited. Then you can't able to work with the wired connection. So everything should be autonomous in some way. So that's why this competition is so challenging, and they have simulation. I think in the initial stage they are testing everything on the simulation. So DERPA actually used Gazebo for the simulation. Okay. Yes, I think there are some interesting images available. You can have a look. Yeah, I think we can just conclude today's session. So maybe next day maybe we can start with the Gazebo plugins. In the meantime, you can have a look on to the DERPA challenge. You will get an idea like where we are using simulation. And so these are some robots, because legged robots, drones are best for this kind of environment. You can see I think it's a spider like robots. Yeah, this robot from, okay, yeah, it's not a easy challenge actually. Yeah. Okay. So that's it, guys. I think if you have any question, you can ask me now. Okay, so I need to conclude for today. Let me know if you have any questions. So we have discussed about the nodal application, and then we have started with the Gazebo. So let me know if you have any question, guys. In the meantime, I can just go through the gallery. So working with this kind of competition now, you will get a lot of understanding about the platform. I mean software platform, because working with the challenges are very good for learning. Okay, your learning rate will be very high when you compete. So if you have time, just involve in some competition, and maybe the failure and success is an outcome only, but the main outcome is the learning only. Okay, so you can learn a lot of stuff, and working with this kind of stuff is not easy. You can see they actually set up a lab inside a cave. See, okay, it's a very difficult challenge. Okay. Yes, I'm appreciating these guys, because they are doing this mainly because of their passion. uh, Nobody will do this kind of stuff if they don't have any interest in this. So like, yeah, that's it. Okay then, guys, if you don't have any doubts, we can conclude, and then see you next week. Okay. Yes, thank you, guys. Thanks for attending. Bye.